Good morning, everyone. My name's Ollie. As Kat said, I'm one of the co-founders of Outfield. I'm also the Outfield Operations Director, and that means that I oversee a lot of the drone, the development of the drone systems that we build. I get to take those out and test them with customers. I get to travel around the world, meeting users of the Outfield system, listening to how they deploy it, listening to how they run operations on their farms and the challenges they face. So there we go. That's me standing in an orchard with a drone. Got so many pictures like that. So today we're going to be talking about yield estimates and the current practice of yield estimates, the importance of yield estimates, the difficulties in generating yield estimates. We're going to be talking about the approach that we've taken in Outfield and about how the Outfield system works and about why we think that's a fantastic method for tackling this problem, and then a little bit about how that system can help you, hopefully. So, start out by talking about yield estimates then. And if you're on this call, if you're a farm manager, if you're a field supervisor, if you're an agronomist, then you will know a lot better than I will that yield estimates are so important to the operation of a modern farm. Fruit farming, we're talking about fruit farming here, talking about mostly about apple farming, but fruit farming in general, top fruit farming all comes down to one harvest per year. So you've got that one opportunity to kind of, get it all right and make sure everything goes smoothly. Knowing what that crop is going to look like ahead of time, it just unlocks so many efficiencies throughout the business. There's a plant husbandry aspect to it, of course. Knowing what yield you've got, knowing what quality and what quantity of yield you've got allows you to improve that fruit quality. But there's also so many operational concerns. Knowing what labor costs are going to look like because you know how many fruit need to be picked. Knowing what transport costs you've got because you know how many bins you're going to be getting. Knowing what your storage costs are and how you're going to be laying out that storage. So many costs are directly associated with the amount of yield that's going to be coming out of your orchards. Then, of course, there's all the supply chain questions. So your fruit, it's going to leave your farm and travel through a complicated supply chain on its way to the consumer. Is that supply chain ready to go? Has it been prepared? Has it been primed? Does your sales desk know how many how many pieces of fruit you've got coming? Have you got the right sales contracts in place? Have you got everything prepped there? Does your pack house know what's coming? Is everything prepared? Do you have an understanding of how that fruit's going to be sold in promotions and in campaigns throughout the season? Getting all of that right, so important. And we see when that doesn't go well, we see there's an incredible amount of waste that comes into the comes into the supply chain, that comes into the process. By some estimates, up to 30% of all fruit, of all apples grown in the UK won't make it off the farm simply because they are undersold or they're the wrong quality. And that wastage, that inefficiency, a lot of it can boil down to just not having the right yield estimates. So I said right at the beginning, I get to travel around the world and talk to different farmers, which is just a fantastic part of my job. And I get to visit different farms and see how they tackle this problem. How do they tackle the problem of estimating their yield, of telling how many fruit they're going to be getting when it comes to harvest this season? I talk to farmers who go off just historical data. So they hardly visit the orchard at all. They just look at some spreadsheets of their yields and they just predict off historical trends. And that's worked all right for them in the past. We're starting to see a lot more, we are seeing a changing climate in a lot of places around the world. We're starting to see more once in a generation weather events. And as we see more and more events like that approach of just using that historical data, it really is starting to break down. I meet a lot of farmers who do a lot of manual counting. So they'll dedicate some sample trees across an orchard, maybe 10 trees, maybe 20 trees. They'll go and they'll count those fruit on the trees themselves, or they'll have someone on the farm who does it for them. And they'll use that data to extrapolate and to estimate the yield. And of course, that is, that is pretty much the cutting edge. Up until a few years ago, that was the cutting edge of technology. That was the best that you could do. It's incredibly time consuming if you're the one who has to go and do that fruit counting. If you're sending someone else out to go and do it, are they following the right process? Are they getting consistent counts? The counts off a single apple tree might vary whether you do them just before lunchtime or just after lunchtime. So are you getting consistent counts across your sites? Are you getting consistent counts across your season? And then I meet farmers who just use intuition, right? So you've got these farmers, maybe maybe a little bit more experienced, maybe a slightly older generation, who can just walk into an orchard, take a look at it, and go, "Yep, it's going to be this many tons. It's going to be this many bins." And that is such a fantastic, such a powerful skill set. There is no substitute for that experience. But what we're seeing is those skills are starting to retire out of the industry. We are starting to see a generational churn, a generational change. That expertise, whether it's the farm owner, whether it's your uncle, your grandfather, your father, whether it's an experienced employee that you've had on the farm for years and years, those skills are starting to retire out the industry, and we need something scalable and something that can replace that experience. And estimating yield is hard. Apple crops in particular, that's where the outfield system operates at the moment. Apples, pears, peaches, nectarines, top fruit we're talking about here. It's hard to get those yield estimates. The crop is very three-dimensional, right? Rather than more arable farming. It's a complex system. Inputs from blossom, inputs from weather, irrigation, pests and disease. There's a lot of variability across the orchard. You've got tree by tree variability. You've got variability on individual rows, and then you've got variability across the orchard in different zones and different patches of the orchard. Getting yield estimates is labor intensive. Especially if you're relying on hand count data, it takes a long time to send someone out to get that data. Counting individual trees is slow, and as I mentioned before, it can be very inconsistent. It's difficult to have a single process and a single procedure for how for how apples get counted and how that gets recorded. Gathering, compiling, interpreting those manual hand counts and turning them into yield estimates, that eats up a huge amount of farm manager or of supervisor time. There's a delay in decision making, and it doesn't give you the data you need to respond quickly, and it doesn't give you data that you can quickly and easily rely on in future seasons. Is it in a format where you can just you can use it in future seasons, or does it all have to be digitized and put onto spreadsheets and recorded in notepads and binders? There's a particular quote, or a particular example, of a farm that we've been working with quite a lot in Michigan in the United States. Big farm called Riveridge, who run multiple farm sites across Western Michigan. And they've got a lot of very high capacity, very high density production, but they have a real problem with yield estimation across these multiple farm sites. The sites are, a half-hour, 45-minute drive from each other. Each one covers, a couple of hundred hectares. And so trying to generate those yield estimates all at the same time, all to the same accuracy, all to the same consistency, all in the same place is a really big challenge for them. There's a quote from the innovation manager at Riveridge. "It is a real challenge to estimate yield as a business when each farm manager has a different method for calculating yield. If I can find a solution that is scalable, easy to use, and I can roll out across the team, it would certainly make a difference." So estimating yield is just hard. So is there a way to solve this? Can technology solve this problem for us? And I think there's a sort of a widespread understanding in the industry that it can and it should. There are a few technological advances which have come along in the last 5-10 years that are really starting to give us the tools where we can tackle this problem and others in the industry, but specifically yield estimation. In recent years, we've seen the advent of very high accuracy and affordable high resolution camera systems. We've seen much better machine learning, computer vision. We've started to see cloud computing and better mobile coverage, so 4G and 5G coverage rolling out across the world. So these technologies, the individual bits of technology, they are maturing, they are available, and you may not think that these technologies are going to be coming to a fruit farm near you, but I think you'd be surprised. I think they'll be there a lot sooner than you think. So, having said that, the webinar today, I'm going to be talking quite a bit about the outfield system and about how we tackle this problem of generating yield estimates. If you know anything about the outfield system, you probably know that we use drones. We use drones to gather our data across farms. Why have we chosen to use drones? I guess it is a question I get asked sometimes. Why don't you use this system, or why didn't you do it like this? Why have you used drones? The answer for that is, I guess, first of all, that drone technology really has matured in the last, even in the last 6-7 years since I've been running outfield. We've seen a huge increase in the maturity of these systems. Your modern drone systems will fly for 30 minutes on a single battery. They've got a very high resolution 20 megapixel, 40 megapixel camera strapped to the front of them. They've got obstacle avoidance, so they won't fly into a tree, they won't fly into a building. They're easy to use. They've got GPS, so they'll guide themselves. They'll execute their own automated flights. And they've got fantastic interoperability with mobile systems, whether Android, iOS, tablet devices, fantastic integration with apps and systems to use them. Drones as a system, as a technology, are accessible. They're very widely available. You can buy these systems all over the world. They always operate the same all over the world. They are man-portable. They're highly affordable when compared to a piece of large machinery, a large piece of dedicated machinery for doing yield estimates. Something like a drone, which folds down into a small suitcase or even into a small carry bag, is something that's very affordable. It's something that's easy to store. It's easy to deploy on the farm. But mostly, the reason we use drones is they are very fast. They can get around a large orchard of many hectares very quickly. They can visit all the different areas of the orchard. They can gather those images quickly and return back to the user with that data very quickly. They require limited resources on farm to use. Because of that speed, they're not requiring hours and hours of manpower to operate a system or to gather manual data. So when we're using drones, it kind of feeds into a bigger philosophy which we have, which is that fundamentally we're generating data. We're trying to generate data for fruit growers to help their systems, help their farms be more efficient, be more profitable, be more sustainable. We're trying to democratize access to that data. So we're always looking for systems which can be deployed on 95% of the world's fruit farms, not just systems that only work here in the UK or only work in America. We're trying to build systems that are easy to use, that are low cost, that get you quick results, and that can generate data that can be used in other systems. So generate data in standardized formats that can be integrated and used with other smart farming systems that you might be using. So talking a bit about the outfield system, some of you may have seen this before, some of you might be familiar. There's a little video up on the screen here just showing you the outfield web app. Everything we do runs through the web app, so it becomes a one-stop shop for growers, for users of the system. It's accessible from anywhere, it's browser-based, so you can log on any time of the day. Anyone in your team can log on and see that information, get that data. It's very easy to add new orchards. It's very easy to manage your orchards. Your data is stored through the web app, so you can access it anytime. You can access previous seasons. You can go back and look at data from this season, from last season. And you can get all of your flight plans for drones. You can do all your drone control, all of your all of your flight planning all through the app. So it becomes a one-stop shop for everything you need for outfield. So, tell you a little bit more about the outfield system then. The session is called Making Manual Yield Estimates a Thing of the Past, and that is really what we're doing here. We are, our goal is to build a system that allows growers to do just that, make manual yield estimates a thing of the past. When we're building the system, we're trying to make it as easy as possible, a really clear flow for the user in using the system. And we can really summarize it in sort of 4 steps. If you're using the outfield system, generating yield estimates, you really just need to do 4 things. You get yourself a compatible drone, you launch it using one of the outfield flight plans that's created through the web app, you get your data back in 24 hours, you use your data. So breaking down those kind of 4 steps, the outfield system has been built to work with what we call consumer photography drones. And really that's just a way of saying, photography drones that you might take on holiday, or drones that you might use for taking pictures of a wedding, taking on holiday, taking out hiking with you. That kind of easy to use, really high resolution camera drone that are widely accessible and widely available all over the world. That's the type of drone that we're using. We've made the system work with a whole range of these different drones. We're adding more all the time. So you get yourself a compatible drone. The idea is that the drone is owned by the farm. It's on site. It's on premises. It can be used when you want to get data when you need it. Flying the drone, we've made that as simple as possible. We generate flight plans for you. Those flight plans drop straight into the drone. It's very easy to drop them in. You launch the drone with 1 click from a mobile device. You do it from your phone, do it from a tablet. The drone will take off automatically. It'll fly itself across the field automatically. It will return to you and land itself automatically. You then just take the photos out of the drone, so a little SD card, pop that out, put it in your computer, upload those photos to the outfield system. And again, all that happens through the web app, very easy to use. Send us those images, and the processing happens in the cloud. So cloud-based processing systems there, which mean that we can turn those data sets around very quickly. We can get results back to you within 24 hours. Maps, yield estimates, giving you the information that you're looking for, the information that you need. And then we can turn those maps into actionable data, actionable insights for the farm. We've got a few different, I think we've got 2 different precision spray integrations at the moment and 1 precision fertilizer application integration. We're always looking for more integration. So if that's something you're interested in, if you want to be able to use this data to drive GPS-guided sprayers, GPS-guided fertilizer spreaders, do drop us a line. Do get in touch, because we're always looking for more integrations there. What else do I need to say about this? I think that's it. That really is it. It really is a very simple flow that we're trying to build. That's kind of the philosophy that we're going with. In terms of using the system, it's very easy to get set up yourself. You can get set up in a matter of hours, onboarding and drawing your boundaries onto the system. If you've already got them drawn up in if you've got them digitized in a different platform, we can make use of that as well. If you want to train up one of your team members, so if you've got a team member on your farm, on your team, that you want to use the system, very easy to get them onboarded. It's easy to have users using the system, multiple drone units able to cover wide areas at the same time. And so this is what the drone sees. This is the drone's view of an orchard as it moves across. Down in the bottom right corner, there's a little view of the drone flying across an orchard and covering a whole bunch of what we call waypoints, which are GPS positions that the drone has to hit. The drone will execute those in order. So number 1, 2, 3, following these positions across the orchard. At each one, it does a certain action, or it carries out carries out certain actions. And so you can see as it moves across, the camera pauses because that's it taking a photo. The view you can see of the orchard is very clear, it's very clean. We line the drone up so it sees the side of the orchard, it gets a very clear view of the trees. It can cover the whole orchard very quickly, so it's finished doing one corner now, and it's working its way across the middle of the orchard. And as it goes across, this survey will probably take about, well, the time estimate down I can see there in the bottom left corner is about 8 minutes. So that's the view from the drone. And what we're looking at here, this video here, is captured from the flight control system we use. We use a third-party flight control system to make flying that drone really easy and make it just a single click of a button. We do support 2 different types of flight control app, with a third one on the way. And so there's flexibility there. There's different options there to make a system that works best for you and kind of configures to your needs, to the needs of your farm and the systems that you're using. And this is what it's all about. This is why we're flying a drone. This is why we're taking that time to make those flight plans, put them into the drone, and fly it over the orchard. We're generating map data and spatial data of what's going on in the orchard. On the left-hand side there, we've got what we call a variability map. It's a heat map showing you the amount of fruit loading across that orchard. So the dark blue areas, we've got a lot heavier fruit loading on the trees. I can see the scale down there, the resolution, you might not be able to see the resolution there, but those are about 180 to 200 fruit on the trees. It says so on the scale at the bottom, in those dark blue areas. In those lighter areas, 20 to 40 fruit per tree, so a lot lighter. There's clearly something going on that right-hand side, that eastern edge of the orchard. Maybe the boundary wasn't drawn correctly. Maybe there's a different variety that's been planted, or maybe something else is going on. But that data, giving that data to the farmer, giving that data to the field manager, the supervisor, lets them go and look at that, lets them go and investigate that in more detail. So we then take those heat maps of where that fruit is, and we turn them into a yield estimate. And that's what you're looking at on the right-hand side. So we've broken this down into 3 different zones: our lowest producing areas, our medium producing areas, and our highest producing areas of the orchard. We've broken it down with a tons per hectare estimate. So that green area, we're predicting 66 to 96 tons per hectare is what we're going to be pulling out of those areas. If you're planning yield, if you're trying to plan bin placement, if you're trying to plan picking teams, if you want to know how many fruit are going to be taken out of this orchard over the course of 1 or 2 days of harvest, this is the kind of data, these are the kind of maps that you want to see, that you're going to be needing. And so, I said that we've made the system as easy to use as possible, and that is the feedback that we're getting from our users. One of the things they really love about the system is the easy workflow, the easy use, the ease of use of the system. This is kind of view, I guess you'd say, under the hood, the Americans would say, under the hood of the system. We don't typically show many images like this. This is really kind of what the system's doing in the background. We've done a visualization here on the right-hand side showing you what the system sees. On the left, that is an image straight out of the drone. There's no editing, nothing funny going on there. That's just come straight off the drone. That's an image of the orchard. We've got presentation of 2 or 3 rows of trees. The drone has got a really clear view of the whole tree from top to bottom, so we can see that whole side canopy of the tree. The resolution of the camera, I mean, you might be able to see it there on this Zoom call, but the resolution of the camera is good enough that we can see loads of fruit on the side of the tree. We can see those whole fruit on the outside, and we can also see those partially obscured fruit that are a little bit more hidden inside the tree. We run those we take those images straight from the drone, and we run them through our computer vision based systems. We use a range of deep learning based systems to extract features from the image. So that's what we're looking at on the right hand side. Green boxes, the system has identified each of those as being a target, as being a tree, and it's done a very good job there. So it's found all those trees in the image, and then on each tree it's going through and it's working out how many fruit it can see as well, and it's highlighting those in pink. And I hope you can see that again on the resolution through the call. We take this data and we pull this data together to give us that yield estimate, to give us that fruit count across the whole orchard. And this is where the real power of the drones, as a platform, comes in. This drone will be able to whiz around the orchard, gathering images like this all across the orchard, covering all different zones, all different sections of the orchard. We can change up the flight plan, so we can gather more images in one part of the orchard. We can gather fewer images in another part of the orchard. We can speed it up by gathering fewer images and just getting a kind of an overview of what's going on in the orchard. Or we can slow it down. We can get a much more high resolution view of what's going on in a much more granular detail. We've got that flexibility and that ability to change that data gathering very quickly and very configurably. Again, making a system that is configurable to your farm and that works for your farm, getting you the data that you need. So that's kind of the view of what's going on, kind of behind the scenes on our outfield servers, churning away in order to generate those maps for you, whether those fruit counting maps or those yield maps. And, kind of like what results do we get from that? Well, on high density plantings, Gala and Braeburn, those kind of flagship varieties, for high density single leader plantings, we've seen a less than 5% error rate when compared against the actual yield coming out the orchard. Now, it's a little bit of a difficult number to calculate because you've got to work out you've got to take into account loss during the picking process and quality issues and things like that. But once that's been accounted for on those high density, and by that we mean sort of 1.2 meter or closer spacing on the trees, high density single leader plantings, we see a less than 5% error rate. Now, the system does work on other types of planting as well. So we've tested the system out on much bigger, much bushier trees. It will still give you fantastic heat maps showing you what you've got across the orchard. We've also got a process where you can do a little bit of counting if it's a particularly difficult tree structure to work with, or very bushy trees. You can do a little bit of hand counting to kind of give it an anchor point so the system knows what it's dealing with. If a lot of those fruit are hidden right in the middle of the canopy. So you can, there's options there to be able to use this on other planting types. We do quite a lot of work with V4 canopies, pear canopies, which is quite common here in Europe, in the Netherlands, Belgium, and here in the UK. And we're also starting to work more with V trellis systems. So quite common in Australia, quite common in the US, especially in the northwest of the US. And the idea that we're going with, the idea is that we can get you more data and we can get it for you more frequently. We can start picking up data. We can start doing fruit counts at 40 millimeter fruit size. So that's early on in the season. 40 millimeter fruit size, about golf ball size. The system starts picking up those fruit reliably. We can start generating maps of where those fruit are, helping you to guide fruit load management, so thinning, hand thinning, growth regulation. You can start generating those fruit counts, and you can start generating those yield estimates. And because the system is so quick to use, because a single drone flight for an orchard, only takes a few minutes. 10 hectares take about 30 minutes to survey, or maybe a little less. And 10 hectares, a single 10-hectare orchard can be done on one battery. Because the system's so quick, the idea is that you're able to generate those yield estimates multiple times between that 40 millimeter fruit stage right the way up to the day before harvest. Really regular data, really regular yield estimates, more data, more frequently, giving you the data that you need to make those decisions, giving you those actionable insights to be used on the farm. So the idea of the outfield system is that it's allowing growers and farmers to work exactly the way they do now, just without the need to do that manual yield estimation, that manual fruit counting. We're reducing that requirement to do those in-field yield estimates, giving you a consistent and uniform way of estimating yield, uniform across your season, uniform across different orchards, across different farms, and uniform across different seasons. So it'll generate the same yield estimates in 2022 as it does in 2023 in the same way. Also giving you that data once that data is in the system, you can always go back and view it. We can always reprocess it. If systems get upgraded, you've got that data there that can be reprocessed. We can regenerate those yield estimates. That data is available to you. Those maps can always be downloaded. You've got that historical record. And as you start to use the system over multiple seasons, those records start to build on top of each other and become so much more valuable than the individual surveys. Having that view of the orchard across 3, 4, 5 seasons gives you real power and real insight into what that orchard is doing and how to maximize and get the best out of it. Using the outfield system, you fly the drone whenever you want. So the drone, you own the hardware belongs to you. We're providing you the means to make these drones work on your farm. We're providing the software to make them a useful tool for today's fruit farms. You can fly the drone when you want. You can gather that data when you want, get those insights when you want. With the goal, the goal ultimately for us is to increase that efficiency on farm and reduce that waste, trying to take that, up to 30% number and try and get that down as low as possible, either by getting the correct number of fruit on the tree, so getting that correct fruit quality, or by giving farmers and sales desks and marketers, getting them forward visibility on what's in the orchard so they know what to do with that fruit. So all fruit kind of has a home to go to. Or whether it's through optimizing and making the in-field decisions and the harvest decisions more effective and more efficient by deploying those resources more effectively, helping you to manage your labor and manage your workforce more effectively. So I've talked a lot about yield estimation, and we are just at the end of this presentation, so I'm not going to go much more. But the outfield system does do more than apple counting. We also built the system to do blossom counting. Talk more about that on the next slide. But we're also testing out canopy estimation. So looking at, we get that really clear view of the trees, as you saw in the earlier image. So we can see that really clear view of what each tree is doing. Can we quantify that and give you data on where you've got better growth, where you've got better vigor in the orchard, starting to map that out? And those are the trials that we've done, combining that with precision fertilizer application. So making sure that you really are getting the best out of getting the most out of these assets. And for us, an orchard is an asset, right? It's something you've invested in, you've planted, you're going to be using that orchard for 10, 15 years, longer for pears, making sure you're getting the most out of it. And we're always interested in trying out new, weird and wonderful things. So if there are other things that you want to know about, do get in touch with us, because we're always experimenting and trying to push the boundaries of what we can do as technology. So I did mention that we do blossom mapping, and really the idea there is that it complements your fruit maps. There's the fruit maps I showed you before. We generate those, we make those blue and white. Our blossom maps are a very attractive shade of pink, nice pink and white. And so again, it's a heat map showing you that distribution of blossom loading across the orchard. So on this map here, we've just superimposed it over the orchard. Those dark pink areas, you've got a lot more blossom there. The lighter white areas have less blossom on them. Now that might be because there's just fewer blossom in the orchard, or that patch of the orchard may have finished its blossom. But because the system's so quick to use, you can do multiple surveys. You can get a really clear view of how that blossom is changing, especially if you're in a climate where you have very protracted, very elongated blossom periods, such as all of our growers in South Africa. Managing that blossom across a blossom period which stretches over 2 or even 3 weeks can be very challenging. And they need that data, they need that visibility on what's going on. Blossom is also the first opportunity you get to look at what your crop might be. Now, we're not doing yield estimation from blossom counts. That is a very complicated problem. It's something we're thinking about in the future, but it's really not something we're able to do now. I don't think anyone's able to do that now. But it really does give you an indication of what this orchard's going to be doing this year, kind of the temperament for the orchard across the year. So that's your first opportunity to look at it. And we've had really good feedback from growers as well on our blossoms. And I should say that blossom is the one area where we've done the most integration with precision spray systems. We can take outfield blossom maps that have been generated for your farm and very quickly turn them into precision spray maps that can be dropped right into your GPS guided sprayer so that you can be doing blossom thinning application across your orchard. That's it. That's it from me. Thank you very much for listening. We talked a bit about yield estimates, why they're so important, about the difficulty of generating them, and about how we see that data.